Hello guys, it's me again, your tutor. My name is Michael Awole, PhD, a lecturer and researcher at the Openfumolo University, Nigeria. Today I'm going to be talking about production system. We are going to be talking about the production types and classifications. But under that, we're going to see what is batch production or batch processing, mass production, continuous production. We're going to see the differences of machinery in terms of machinery, materials handling, and labor. We're going to be seeing it in terms of the output as well. And then at the end of the day, we want to see scheduling. What is scheduling? We're going to see the various components of scheduling and how this is done practically. Thank you. Cheers. But then don't forget to click subscribe button. At the same time, don't forget to click on the notification button as well so as to get notified for subsequent videos I'm going to be posting. Thank you. Cheers. And let's go now.
Production management
is defined as the process by which combines and transforms various resources used in the production operations of system of an organization. And these are converted into value-added products or services in a controlled manner as by the policies or rules or regulations of the organization. What are we saying? This is telling us that production and operations management is a process which combines, is a combination of inputs, combines inputs. If you look at that, combines so many things into inputs. And what are those things that are combined within the input section? Combination of resources, combines resources together. And what are those resources we're talking about? Human is a resource. Time is a resource. Money in itself is also a resource. So production subsystem is a combination of resources, of human resources, funds, time, function. A code is that you don't in an optimal manner. The funds must be optimal, the time must be maximized, as well as the humans that will be used for different things have to be optimized as well. It should not be too much. So that is word control. And then the transformation in the definition now happens within the processing, within the processor aspect. When the input is coming, it will land or pass through the processor. The processor will perform the work of transformation, will transform all the inputs that have been fed in terms of time, in terms of the human resource, in terms of capital, in terms of the raw materials, and every other resource we can think about in an organization that is useful, that the organization is put into use. And after that, the next thing now is to generate the output. The output would definitely come as value added. If it's not value added, then what then would the people in the market will they pay for? You pay for your mobile phone because you can see some value added on that mobile phone. You pay for so many things that you buy because you can get value from what you paid for. And that's why, so the output here has to be value added. Then everything that was combined together within this section or subsystem must have been regulated by the organizational rules or policies. So if you look at that definition as a whole, it has a number of keywords which you have to explain when the examiner is asking you to say one or two things about it. So production operations management is a process which combines and transforms various resources used in the production operations of system of the organization into value-added products and services in a
production management.
So if the examiner is asking you to explain what is meant by some of these keywords within that definition, you should be able to explain it. Or if you are even asked that, what is production of operations management? This is what is expected of you. After putting down this definition, you are expected to also expatiate on each of those keywords, not just writing this, because nobody will ask to define. Like just once, if you're asked to define, just define and just put those 5 lines back to the examiner. But if your examiner should say that you should, that's what is meaning that all that you know about that particular subject, you have to relate in your write-up. So if I ask you in the exam, for example, or in your test, that what is production and operations management, so this is what I expect from you, to put this down with the grammatical representation and the explanation of each of those key keywords in the definition. So now let's talk about the classifications of production. The production system by itself is classified into about 4 major types, which are job shop, batch production, mass production, and continuous production. Job shop production are characterized by manufacturing of one or few quantity of products. One or few quantity of products. What is this talking about? This is talking about order that are to place. The production is done only when they have received orders. And that is why in some manufacturing industry, when you order for a particular material, it's usually cheaper than you go to pick it up in the shop. Why? Because they take your orders and they go back into the manufacturing line to roll them up within a given period of time. So this is called a job shop production, and it is characterized by the following: high variety of products and low volume. In fact, this Michael Dell started his corporation, Dell Corporation, in 1995. Yes, 1995. And it started by this type of production. We will take orders from different people, from friends, from families. They will give you specification of the type of computer that they want. And he will go to the manufacturer and ask them to produce for him. He will collect everything. So that's why today when you see Dell systems, a particular Dell may definitely be different from the next one. There is no two Dells that are of the same specification. Two Dell that are of the same specification most of the time. So he was using job production classification for his business. So in this case, one of the main characteristics has to do with the fact that it will have high variety of products and low volume. Variety will be there. I want a core high five or a computer system. Somebody will say, oh, I don't want core high five, I think I want Athlon. Somebody will say, I prefer Intel processor. And the clock speed will be different. Somebody will say, oh, let me go for 5.0 clock speed. Another will say, oh, what I want is an 8 gig RAM. Another will say, I want 16 gig RAM with my Core i5. That's why you have a number of high variety of products using job shop production. And low volume because not many people want to order at the same time. So you don't get to produce too many of them. You just have a number of varieties and then low volume. So in that case, one of the demerits, if you look at that from this particular point, is that it's expensive to manage. It's expensive, it is time consuming, and some of the time it's a bit laborious. So another characteristic of job shop production is use of general purpose machines and facilities. The use of general purpose machines are there for them, so you don't have to look for specialized machine to be able to carry out your manufacturing. The facilities are there, the general ones that are there, it's also there. Another one is high-skilled operators who can take up each job as a challenge because of uniqueness. You must have high-skilled operators for each of those units of job that should be done. So, like I said the other time, to get high-skilled operators, you have to pay. You have to pay. You must be ready to pay high-skilled professionals. So, in a way, it's also expensive in terms of labor acquisition. The another one is large inventory of materials, tools, and parts. You have to stock your manufacturing firm with varieties of materials because you do not know which one your customers will be requesting for. So you have large inventory of different materials of different sorts of tools and parts that has to be in place at any point, so that because you never can tell which of the materials your customers will be ordering for. So another one is detailed planning is essential. Detailed planning is essential for sequencing the requirements of each product, capacity for each work center, and other priorities. So you must have detailed planning in place. It's very essential for you to be able to sequence the materials, the human labor that will be used to sequence your inputs, and even your machines as well. So the next one. The next one here is batch production. Just like the name implies, batch, when you produce things in batches, you produce them in batches, you attend to people in batches. Batch production is a form of manufacturing in which the job passes through the following departments in lots, maybe lots of 10, or 20, or 50, or batches, and each lot may have different routines. Batch production is not encouraged in an hospital. So in a manufacturing firm, batch productions are allowed, especially when there is shorter production runs. These are some of the characteristics. Another one is when plants and machinery are flexible. When the machinery, you can just go to the machine and start it up, and it begins to run. Oh, it's so flexible, you don't need a specialist to come and put it on for you. You don't need a specialist to set to a particular threshold before you get to use it. So when the machinery are very flexible and the plant is there to manage so easily, you can involve batch processing. Another one is when plant and machinery setup is used for the production of items in a batch, and change of setup is required for processing the next batch. Take for example now that in the olden days when when there was no proliferation of computers, many people, what they do then is they will just write their program on the punch card. After writing their programs on punch card, they will now go and submit it to the operator that will run the machine. But then they won't run the machine at the same time. You have to be stacking your cards. So when it's enough for the machine to get it started, they will just go there and get the machine started and it will run the program. And then you come back at the later time to collect the output of your program. So I think the same thing is also applicable here in a manufacturing firm where you don't want to produce for just 3 organizations requesting you to do 1 or 2 things in terms of maybe volume, maybe 1,000 volume. Where you can ordinarily produce like 5,000 or 10,000 at a go if you do it in batches. So why do you want to produce 10 now? Another one, once you are finishing with that 10, the next 30 somebody is requesting for another one again. I want to produce for the next 20, another 20 outputs in the next 20 minutes. No, it's not. So you want to wait and put them in batches so that I can save time, you can save cost on the number of things. So another time when batch processing is done or it's used is when manufacturing lead time and cost are lower as compared to job order production. When the lead time has to do with the time that you place the order and the time that you receive it, that's a lag. That is the lag is referred to as the lead time. So when the manufacturing lead time and cost are lower and compared to job order production. Another one is mass production. Manufacture of discrete parts or assemblies using a continuous process are called mass production. What is this telling us? You mass produce. I'm sure you're all familiar with it. You must have used that word very well, extensively in the past. Most of the time, mass production involves continuous production process and what you need. Take for example, when you want to produce, the machines you want to use for this mass production. There are some machines. Take for example, let's use steel company where they produce steel. Before you finish that machine can be ready, you may have to start it, and the next 8 hours it has not gotten to the required threshold, the required temperature you need to begin to melt the iron. So when you start a machine and you are waiting for 8 hours to get heated up, number one, you cannot afford to lose electricity. You cannot afford, after heating it up to 8 hours, and then you begin your production. You cannot afford to shut it down again for the next 1 hour, and then wait another 8 hours again to reprocess others. No. So that is why you have to wait and treat those productions together in mass. So if you produce, you roll it out in mass. You roll it out because you don't want to be doing it bit by bit. You roll it out. And these are some of the characteristics of mass production. Mass production, like I said, is a discrete parts or assemblies using continuous process in manufacturing. The procedure to follow in mass production for the machines, they are standardized in such a way that you already know that once we are done with treating with machine 1, once we are finished with machine 1, take for example in a bottling company, once you have already fed in the bottles, the empty bottles, a machine is to feed in the bottles to put the content in the bottles. Once that one is done in mass, maybe like 20,000 bottles or 1 million bottles produced at the same time, the machine A, for example, will pass it on to the next machine B. So that process is standardized. Maybe after 10 minutes that you have been filling it up, once you are done with that 10 minutes, move it to machine B. And as you get to machine B, this is what we are going to do. You sequence that as well. Stay for under machine B for another 15 minutes. And once you are done 15 minutes, after you have done 15 minutes in machine B, these are the procedures that you have to do. Put the cork and cork it. After 15 minutes, that you have processed that part, move again to the next one. Process them in mass as well for a number of minutes and following a given standardized procedure. The other characteristic of mass production is dedicated special purpose machines having higher production capacities and output rates. You know, like I said, output rate of that particular machine is high. It can roll out maybe in 1,000 at a time. When it's bringing out the output, it's 1,000. Go and fetch another 1,000 in again, process it, feed it in, roll out another 1,000, bring another one. You know, they have capacities. These machines that they use for this special purpose production, they have capacity, high capacity for output, high output rates. Then it is also characterized by large volume of products. In mass production, it is characterized by large volume of products. You produce high volume. It is not a situation whereby you just produce only 5, you wait again for another time, intermittent. No, it is not intermittent in nature. It is continuous. So, but as it's rolling it out in mass. Another characteristic is shorter cycle time of production. That's shorter cycle time of production. It doesn't take too much time to complete the cycle of production because it is already, the algorithm is there, the procedure is standardized. So with this short time, the production is set to give you the desired added value, to give you the desired output. It's also characterized by lower in process inventory. So you don't have to bring in too many varieties of materials. You don't have to stock so many varieties of materials. You already know that once we are producing in our factory today, what we are going to do is we already know that we are bringing in this number. The standard is already there. Every day we are producing 1 million bottles. It will not change from tomorrow. If anything must change tomorrow, then you have to look at some of the things that you have standardized. So you already know that you have 1 million production of bottles of beer, of your bottles of drinks, or whatever you are producing. You already know the input, the required input that will be necessary. So you already have those ones in stock. There is no need for you now to begin to be stocking your store or your storage with relevant varieties, which is the main characteristics of the batch processing as well as the job shop production. The other one here is continuous production. Continuous production facilities are really as by the sequence of production operations. From the first operation to the finished product, the items are made to flow through the sequence of operations, through the material handling devices such as conveyor belts, transfer devices, and so on and so forth. So the continuous production is there. Because it's like, I don't know whether you have seen conveyor belts before. If you have traveled out, you have not seen it in any manufacturing firm. You must have seen the conveyor belt at the airport. The conveyor belt is normally used to put all the loads. The conveyor belt will be going around in circles so that people can come and pick their loads. But the conveyor belt in the manufacturing firm would convey a particular material from a machine without the intervention of humans. It will convey the material from a particular machine in a continuous mode, and it will pass it on to another machine. What it is done with that machine as well, it will carry that material again, further it to another machine, and so on. So the items are made to flow through that sequence of operation, through the material handling devices and transfer devices. So this is characterized by the following. Continuous production is used under the following circumstances: when we have dedicated plants and equipment with zero flexibility. We have dedicated plants, machineries are dedicated for a particular task, and there is no flexibility such that, oh, the machine has started, is a particular machine supposed to run for 10 minutes, and you're like, oh, I don't want it to run for, let me quickly stop it now and then return it back to 5 minutes. It will affect the rest of the machines that are waiting for that input, which is to come from that machine here. So flexibility in that environment is not allowed. So the next one is when material handling is fully automated, it must have been programmed. You may not have to do any intervention. Program means start the machine, go your way, come back again and fetch it. It's not like I have used the washing machine in the past that has, once you take your clothes there, the soap is already there in different compartments, the water is there in different compartments. Once you take it there, it will wash for you, it will rinse for you, it will dry for you. So all you just need to do is just set the time for all of that. You only need to set the time, say, for 5 minutes. So it will, the machine by itself will automatically set the time for washing, for rinsing, and for drying. So when you get back there in 45 minutes, you already know that, oh, this is a priority job. I have to finish all of this in 45 minutes. I come back and just pick your clothes within that, in the washing machine within the given period of time. So the same way is applicable here. When the machine is already set, different times have already been put in the procedure for them to work. Then the other characteristics of this continuous production is material handling is fully automated. I think I mentioned that. Then another one is process follows a predetermined sequence of operations. Predetermined sequence, as a sequence of operation for the number of jobs to be done at a point in time, for the number of seconds, number of minutes, number of hours to be done, to be given to a particular machine at a point in time. This is what we're going to be doing in scheduling when we begin the calculations. We're going to be doing some calculation in scheduling. You will see a sample of that question at the end of this class. We'll see that now. So this is what it's talking about. So the number of jobs to be processed by a particular machine will have been assigned. The number of time, the number of milliseconds or hours to spend with that machine must have been allocated and be predetermined and put into that sequence of operation. So another one is components materials cannot be readily identified with final products. Cannot be readily identified with final product. Sorry. Another one is planning. Planning and scheduling is a routine action. The planning and scheduling for continuous production is a routine action because that's what we did yesterday when we want to do our production. We already know what to do. We know that at 8 a.m. put on the machine. Once you put on the machine, you know that by 9 a.m. it's also ready in the next 1 hour from 3 days and 9. It's ready for you now to begin to ask the first machine to begin to put the content. So after working for another 2 hours of the machine putting in the content, press the button again for the next one to start up its own process. So it's a routine process that is applicable for continuous production. Now, let's look at the differences on the basis of output. Differences of some of these types of production subsystem on the basis of output. You find out that when you want to categorize them, the batch production, process, continuous production, and what have you. On the basis of the output that they generate, some of them are various products. Their outputs, they have varieties of products that they produce. Heterogeneous products, they don't produce the same products, varied products. And then another one is uniform. Some of them have uniform products that they bring out all the time. They already know that once this machine is up, it's bringing out a bottled water at the end of the day. I mean, sets of bottled water at the end of the day. But another one that has intermittent productions. Take for example the job shop. For example, can produce maybe 14-inch laptop with different controllers. In the next 2 hours again, if you configure the game to bring in another type of operation, another maybe like another 10-inch computer system, because of the varieties. So another one is the volume of outputs that they produce. Like I said, in the continuous production, they produce a mass. Intermittent production, they may not necessarily produce in mass. Most of the time, they produce in bits. They produce in small volumes. So when you have to differentiate them on the basis of output, this is what you're expected to talk about. You're expected to categorize those types into the varieties, those ones that are responsible for the varieties, those ones whose outputs are heterogeneous, those ones whose outputs are homogeneous. You're expected to classify them this way. And then, if you look at relationship here, this is the chart that will show the relationship, interrelationship of the production types as well as their characteristics. Now, if you look at the flow production is also job production. It's also job shop production. The flow production is talking about when you receive the order, like I said, you receive the order and you go into the manufacturer. But look at the intermittent that you just produce when you receive the order, like the job shop, the job order, or batch production. They have varieties of products, they are heterogeneous products in nature, and that is why their uniformity is low. They're not uniform, they don't produce uniform products. They have different products that they produce, and that's why you find out that the heterogeneity is high, the variability is high for the intermittent products of batch production as well as job order. Now, if you look at the differences on the basis of machinery, like I said, we have both continuous, non-stop. Once the machine gets started, it will not stop until the end of the final output is out. The intermittent, like I said, intermittent, do it now, do it in batches, come again, do another set, and you move on. So these are some of the characteristics in terms of the base of machinery. Now, we have specific machinery that are meant for continuous production. That's specific machinery that are meant for continuous production. Then they also have specific machine setup. The setup is there, specific machine setup is there, you cannot vary it. If there is any need for you to vary it, you vary machine A to affect machine B, because that was not the way you set it up last night. That was not the same way you set it up last week for the same number of production. So we also have another characteristic of that, of the continuous, is also duplication of machines. It has flexibility for duplication of machines. Now, if you look at the intermittent, they have generalized machinery applicable here, because the machinery that is used to produce Topomilo is the same one that is used to produce Maggi, because they are keeps. They are both keeps. So another one is frequent changes in machine setup. To produce another product, once you, because of the flexibility, you can adjust maybe the size to give you a bigger size of your end product. So the intermittent machinery will permit you for the flexibility in the adjustment of the machine, so as to produce to meet the demand for the various products expected at the end of the day. Then less machines are required. Not many machines are required for this type of operation. Then difference on the basis of materials handling and labor. Differences on the basis of materials and labor. For the continuous production, people that you know that they can operate, so this operator can operate this machine very well. They may not necessarily need to be skilled. You know, another one is mechanized material handling. The material handling is automated. The material handling must be mechanized so that you can even bring in your artificial intelligence. You already set that go and pick this material full time, set the threshold to 5.0, for example. Raise your machine, raise the head of the machine to 5 degrees, or to a particular height, maybe 5 centimeter. After 5 minutes, you bring it down again 2 centimeter, and the material handling is mechanized and can also be set. Cost is also less. To handle the material is also less. Why? Because you do not stock varieties of parts. You do not stock varieties of products. I mean, the varieties of inputs. The number of inputs required, you already know. Then in that case, investment in inventory is high because you need large warehouse to put your materials. Then the intermittence is for intermittence, who can easily say, oh, wait a minute, I think what we have been doing in the past is we have to ensure that this machine is set to this number. They will go to, so you need highly skilled labor force to handle intermittent production. Any production that is coming from job shop, which is through order, will definitely be more expensive than what we have when you do mass production. That is why when you do mass production, the unit cost of any product that is put into mass production will definitely come down, will definitely be cheaper than what obtains when you do intermittent production. So another characteristic of that is that it's not feasible to employ mechanized handling. You cannot do mechanized handling here because if you automate the machine, that once you have done this, you have to do this again, and then you now find out that you have to change. You have to, because for other varieties, once you are done with that, maybe you have only produced like 1,000, and then the next 1,000 products you want to produce after that, it's coming with a variety. So your automation will be zero. To mechanize that, it will be difficult. So you wouldn't want to do that. So high cost of material handling, like I said, you now have to spend more to be able to handle your materials. Then there is need for inventory. Need for inventory is minimized. In this case, you don't have to stock too many things. There's no need for you to stock a number of things because you have to minimize your inventory in intermittent production stream. Then you look at the difference on the basis of what we have said a few about this the other time. For continuous production, example of that is mass production, like I said. Few standard products are produced in large quantities. Few standard products, not many of them, not many varieties. A few of them are produced in large. Take for example, production of ships, production of aeroplanes. Large, few standard products, they are produced in large quantities. Also production of even clothes can be done in large quantities. The another characteristic of this is that output on the basis of anticipation of demand. You are not sure. Look at those people, the Boeing company, for example, that manufacture planes. They do not know which customer is coming at a point in time. So they are producing on the basis of that the demand is likely to be higher this year, so let's produce more. The demand is likely to be higher next year, so let's produce more. So, but if you look at the production, the output produced in intermittent range, we have wide range of products in small quantities. Wide range of products in small quantities, different varieties. So as we do this production, let us produce 500 of these, and then another varieties, 200 of these, another varieties, 300 of that. It's also characterized by output according to order received. You don't produce until you have received the order. So outputs according to order received. So scheduling is another topic entirely, which we are going to start. I just want to introduce it to it, mention a few things there today, and then tomorrow we are going to do a few things there. We're going to do some calculations there. So this determines the order. Scheduling determines the order in which the jobs assigned to a machine or a group of machines will be processed. Scheduling has to do with, most of the time you say this is your schedule. This is what you have to do. The same thing is we are going to schedule for both humans and for machines. So each job is characterized by its routine that specifies the information about the operations to be performed. It's not going to say the sequence of the operations. The sequence of these operations. So that let's say you have machines A, B, and C, and then you have jobs A, B, C, D. Which job is to be processed first? So let's start with job A, or job B, or job C, and at the end of the day, because at the end of the day, I'm looking for the procedure that would minimize our time. The procedure that will make our delivery be on time. Rather than us delivering in 30 days, we want a system whereby the procedure and A for response. So there are about 4 operations to perform to carry out job A. We also have 3 operations to perform to carry out job B. B1, B2, B3, respectively. Three jobs. We also have 3 jobs as well to be performed by job C before job C can be fully said to be completed. So, and as they do it, different machines, we have 4 machines to be, 4 machines available for these operations. So for machine A, there are 4 machines: machine 1, machine 2, machine 3, machine 4. And if you look at this, for machine A and operation A1, it is expected that machine 1 will be used for operation A1. And that machine 1 is supposed to work for 5 days. Operation A1 should remain on machine 1 for 5 days. Same goes for operation A2. Should go to once that one is done, the next thing is to go to machine 3, process operation A2 on machine 3, and let that remain there for another 3 days. And the next one is the operation A4, A3, which will spend 7 days in machine. The next thing is operation number 4. Still working on. So the next thing is work on machine 2 for 4 days. And at the end of the day, by the time this is done, the job for machine completed. Or how many days does it take for job A to be completed? Some of you intelligent ones want to add some bits up. We want to sum 5, 3, 7, 4 up, and then say, oh, it's very simple. This is the addition of this that will tell us the number of jobs, the number of days spent by job A to be completed. No, because in between the machines there are time lag, which by inspection you cannot tell. So that is what necessitates what we refer to as Gantt chart. So you have to bring out your Gantt chart to be able to know the actual number of days. Gantt chart flows from left to right, and the number is on top as 1 to 30 in the number of days, and then you begin to fix your operations. We are going to do that next week. So let's see other question that this is asking us. You have to draw a Gantt chart on the workflow sequence using this order A, B, C. If you look at it, the number 2 is saying using order BAC. Number 3 is saying using order CAP. And what this means is follow job A first, treat job A first. Then when job A is done, you move to job B. When job B is done, you move to job C. When job C is done, then that's the end. But for this particular one, for this second one, do not start job A. Rather, let the flow B start with job B, and then go to job A, and then you go to job C. So this is the order that this one should follow as well. Then in the third one, you also have to bring out the Gantt chart as well for the third one. Start with job C, start with job A, followed by job A, and then followed by job B. At the end of the day, you are going to come up with what is referred to as the max span, which is the total time taken for the jobs to be completed. So you now compare the total time taken for the jobs, for the flow, for the order ABC to be completed. You have that. You also compare that of BAC, the number of days. Let's say this one takes 25 days to complete, and this one 27 days to complete, and this one 30 days to complete. Which one will you go for? The entrepreneur is apparently looking for an opportunity to start. So he will go for the minimum max span.